Okay, so what we're going to do this time is hopefully we're going to put all these moves into one for loop and then hopefully figure out a way for the ends to connect like I talked about on last episode. So this part here, making all moves into one for loop, currently what we do is we loop through the board and we check if there's a right move, then we loop through the board again and we check if there's a left move, and then again for an up move and then again for a down move. What we could do instead is just take this part right here and throw it under this loop like this. We'll put this here to let us know what we're doing, so we know that goes there. So we can take that, we can take this, so what this is going to do now, once we comment all this out, is instead of checking for a right move, going through the board, and then going through the board for a left, and going through the board for a right, going through the board for a up and a down and whatnot, this will just go through the board once, and it'll check for each square, can it move right, can it move left, can it move up, can it move down. So what we need is, if it finds one of these, it needs to just continue in the for loop, rather than checking another one. Actually, rather than doing that, what we could do is put these in elifs instead, and then these won't get checked if we find one. So next up is we need to check if ends are touching, and basically what we want is when, so in this case right here, this would be a lowercase g, this would be also a lowercase g. So we want it to recognize that this lowercase g here only has one place to go, and we don't want, because this orange is forced out here, we don't want this lowercase g here to think it's surrounded and now can only go up, like the mistake it made in the last one. So we need it to recognize when there's a square next to it that is also the same as it, and that square then obviously would not be counted as a 0. So instead of having this condition here where it's not equal to 0, we might have if it's not equal to 0 or itself, and then work with some logic from that. So I'm going to work on that now and then be back once I've finished. Okay, so when we check if the element to the left, right, up or down is not equal to 0, we're checking if the element is filled, so if it's like unable to be moved to. What I've tried to do instead is change that logic to, well, keep it the same, like see if it can be moved to, but obviously you can move to things that aren't zeros as long as they are the same thing as you. So if there's two ends, you can move from one end to the other sort of thing. So what I've done here is I've added logic that basically says instead of not equal to 0, it's if it's not in and then a tuple of 0 and then itself. So we're working with an end, so this thing will be an end, but it'll just change depending on what colour end we're with. So I'm going to add this all the way through, but yeah, I just thought I'd explain what I was doing. What this should do is check, it should still do the original thing, like output the original stuff it was, but basically now instead of just checking if it's not equal to 0, it'll also check if it's not equal to itself, and if it is equal to itself, then it knows it can still move there, so it's not necessarily a forced move. So it should solve this green issue we have over here, where green thinks it can only move up. It should now realise it can also move down. So we'll see when I've coded it all and I run it. So I've copied all this over, and now the next bit of logic I'm going to change is equal to 0, I'm going to try replacing this with a similar logic to this. Oops. So instead of equal to 0 is equal to 0, it's going to be in and then this exact thing. So it's going to basically be this. This should now check if the end that we suspect might be left is a 0 or can be another end, and therefore it can still move to it. So this should join up some ends. We're then going to be left with like a single end on its own, so we might have to do some other sort of quick scan through the array to see if there's any colours that have only one end, and if so we'll capitalise that just to sort of end that off, and that would be the end of that flow. So pretty happy with this, think it's going to work. I'll be back once I've done it. Okay, so I've finished that up, now I've ran it, and you'll see you haven't made the same mistake as before. This green hasn't been moved upwards. Obviously the board's still not solved because we're only doing one pass, so what we would do is we'd call this function multiple times using this thing up here, but this is actually wrong. Checking if an array is equal to another array, I'm not certain how you do it, but it's not quite like this, so this is my next step to fix. But basically this is why it's not looping over and over. This is currently being called once and then that's it, it's done. So next up we need to check if there are any single characters on their own. So I expect once we loop through this twice we'd end up with this G capitalized and this one not capitalized. That could then cause a problem because this G could then think it can only move up here. So I would then check the array hopefully for single letters that aren't capitalized and capitalize them. And then next step is to fix the loop up here. So that'll probably be next video. That's this one done. So hopefully you followed along. Quite a lot of stuff we went through in this logic. It's not all obvious what's happening, but have a read through and maybe copy it and run it yourself, and I will see you in the next one.